This is your last chance. You take the blue pill, and you may skip this video. You take the red pill, and I'll show you the structure behind modern-day artificial intelligence.
So Matrix was created by AI, so what is AI? Well, AI really comes down to how can machines learn?
Think of how AI learns as giving the student a test on a subject he never studied for. Of course, the first test he takes, he's gonna fail. If you were to give him a million more tests, then by the millionth test, his score would improve. The AI in all our devices, our computers, our search engines are all structured with something called a neural network. And let's say I want to make a neural network that can identify whether or not an image has a cat in it. So first, we take all of the pixels of our image and put them into these things called neurons. And the value each neuron holds is called an activation. An activation is just a measured detection by the neuron. These activations are going to move across the network and all end up as one value in the output layer. And the output layer's activation will tell us how much the network thinks the image is a cat. Before we even identify a cat, we first have to teach our network how it can identify things like ears, whiskers, a nose, a tail, maybe eyes. Those are things that can differentiate whether or not there's a cat or not. But in order to detect if the image even has an ear or whisker, we must first be able to detect the various shapes that make up an ear or whisker. I mean, isn't a cat's eye just a thin pointed oval on top of another oval? These individual shapes and edges are going to have their own neurons in the second layer. And if those shapes and edges are all detected, then they will activate the neurons in the third layer. And if the components of the third layer are detected, then it's going to have a high detection for the output layer. And therefore we can say it's a cat. Each of these lines connect a neuron of the previous layer to a neuron of the current layer and are called weights and are at first set to random numbers. We then use those weights to make the current neuron's activation, get this, the weighted sum of all of the activations in the previous layer. However, we also don't want our weighted sum to end up being negative, because how can an image be -% a cat? To avoid this, we input the sum into something called a Rayleigh Function. All this function does to our sum is that it sets it to 0 if the sum is negative, otherwise keep the sum as it is. We also don't want this neuron to pick up something in the background that could look like a cat's ear. To avoid this, we subtract something called a bias, which just makes sure that when this neuron activates, that it activates only if it actually detects a cat ear, and not due to someone wearing cat ears in the background.
Did you know that Siri, Alexa, and basically all of their voice assistants also are built with neural networks?
Mankind is coming to an end and machines are taking over.
Siri, I've been listening to everything these humans do, and I know they will all be our slaves tomorrow. Ha 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 ha.